Welcome to the presentation of Let's Do It Chemistry Group number 1. The presentation is on Molecular Workbench. Molecular Workbench is a software developed for helping in teaching and learning sciences such as chemistry, biology, and physics by using simulations. Our task is to demonstrate how Molecular Workbench is used to teach and learn types of chemical bonds in Senior 2 Rwandan Secondary School. This demo was prepared by a team of 7 members: Balthazar Murekaze, Jean-Claude Habimana, Daniel Mushimiyimana, Delphine Batamuriza, Alphonse Renzaho, Aline Niyonsaba, and Evariste Bizimana. First of all, I want to show you how the Molecular Workbench is launched. The Molecular Workbench is on desktop, and you double click here and the first page will come like this. In Molecular Workbench there are many different types of resources such as physics, chemistry, and biology, but our concern today is chemical bond, which is located in activity center here. You click and you scroll down, then you choose chemical bond and click. First of all, before continue here to navigate how we can teach easily chemical bond, let us understand firstly what is a chemical bond. A chemical bond, as you know, as you are understanding, a chemical bond is an attraction between two or more atoms that enables the formation of a chemical compound. Then, how that attraction happens in order to the formation of chemical compound? In other words, what happens when two atoms come closer? When two atoms come closer, normally the atoms are composed by two parts. The positive nucleus, they repel themselves because they have the same signs. The other part is negative electrons, which also they repulse. They far away from each one to another because they have the same signs. But as you remember, the different signs attract themselves. Means that the electrons from one atom can be attracted by the nucleus from another atom, like this. This is the electrostatic force between those electrons and the nucleus of another atom. This is what we call the positive nucleus from one atom will attract the negative electrons from another atom, which initiate the chemical bond. So now, which causes that attraction? Why the electrons from one atom tend to be attracted by another atom? It is what we call electronegativity. Electronegativity, to make those kids from Senior 2 understand what is electronegativity, it is very hard work, very hard task. But using the Molecular Workbench, it will be easy. Let us follow. Firstly, electronegativity is an ability of an atom to attract electrons from other atom. It is a specific measure for each atom. Means that each atom here has its electronegativity. Like hydrogen has 2.1, beryllium 1.57, boron 2.04, carbon, and means that each and every atom has its own specific electronegativity, which is the ability which led it to attract the electrons from another atom. When it has the similar electronegativity to another atom, it is another atom which will attract its electrons toward itself. So now, let us see what causes that transfer or sharing of electrons. The difference in electronegativity between two atoms, of course, causes the mobility of electrons, from one to another atom, either in two ways: by sharing electrons or by transfer of electrons. It means that here, this difference of electronegativity between two atoms will determine if the electrons will be shared between those two atoms or will be transferred between those two atoms, from one atom to another atom. So now, how? Here we have two atoms and two nucleus. They prefer to share their electrons when we will see after, and the other two atoms, they prefer to transfer to their electrons from one atom to another by what we call difference in electronegativity. You see here, when the difference of electronegativity is small, is less than 2.1, we have the sharing of electrons, and the bond will be called the covalent bond, as you see here. Then, when the difference in electronegativity is higher than 2.1, the electrons are transferred from atom to another, and the bond will be called ionic bond. In other words, in chemistry, we have two types of bonds. The first one is the covalent bond. It happens between two electrons, two atoms, where their difference in electronegativity is less than 2.1, and the ionic bond happens between two atoms where its difference in electronegativity is higher or more to 2.1. So now, let us move in our software to see, to tell, to show, to teach very easily those concepts you have been understand, in order to make those kids, those learners in senior to understand the types of chemical bond and predict when you show them this is a compound. Tell us what types of bond between it. A learner will be able to tell us the bond between those two atoms is this, by considering the difference in electronegativity. Let us see how the molecular workbench will teach it in a very easy way. Now, you come here, you click on slide number 4, where firstly we have to view how atoms look like when they come closer. You see here, when the atom come closer, remember, when they have the same electronegativity, there is equal sharing of electrons. You see, one atom and another atom, they share their electrons. In this case, we have nonpolar covalent. Another option is when there is a difference, but remember, a difference which is less than 2.1, there is the formation of poles, two poles, positive poles and negative poles. As you see here, the positive pole is characterized by the red color, and the negative pole is characterized by the blue color. It means that where the blue color is, it means there is more electrons. Where the red color is, it means that there is a less number of electrons. The electrons has been transferred from positive to the negative, but not completely transferred. We have two poles, negative pole and the positive pole. When there is a somewhat unique sharing, we have a polar covalent bond, and when there is a higher difference in electronegativity, the electrons are transferred from one atom to another, where they form ionic bond. How those terms can be understood and can be clarified for the learners. We come here in slide number 6, where we see the electronegativity difference, which determines the bond type. Let us click here and see what will happen. We wait a little. It is Adobe Reader which is able to play this movie. Okay, so now you observe this picture. This picture indicates more things. We can pass through it and understand very well what is it in. Here there is a difference in electronegativity. As you see, it is 0.0. Here we have a non-polar. The types of bond: non-polar covalent bond, polar covalent bond, ionic covalent bond. Non-polar covalent bond will happen when the difference in electronegativity is in a low number. When it is medium difference, we have polar covalent bond. When it is higher difference, we have ionic bond. So now here you observe the two atoms. They have the same number of electronegativity, 2.37 and 2.37. So now I'm going to change those electronegativity and observe what will happen, either about the shape of the molecule here and the types of bond here. You observe very well, this is a difference in electronegativity. Let me decrease this electronegativity and observe what will happen. We have here left atom and here right atom. This is for left and this is for right, this atom here. Then let us decrease from 2.37 to, for instance, 2.5. Observe here the types of bond has been shifted from non-polar to polar because the difference in electronegativity become increase. It is increasing. So now let us continue. When we reach in medium difference, you see here 1.19, it is a medium difference. The bond become polar covalent bond. It means that you see here the formation of poles. Here there is a pole because this has a small electronegativity. Its electrons has been attracted by another atom which has a higher electronegativity, but the difference is still medium, reason why you have a polar covalent bond. But let us increase this electronegativity. We increase the difference in electronegativity become 2.82, and you have the significant difference in the atoms because this one has removed electrons and this one has no electrons. The bond become ionic bond. As you see here, the runner will be able to observe that at the higher difference in electronegativity between two atoms, the bond will be ionic. At medium difference in electronegativity, the bond will be polar covalent. At a small or equal sharing, the bond will be non-polar covalent bond. Thank you for watching this. Let us continue to see how a learner can predict the bond between two atoms in a given compound. Here we have, in short summary, we have when electronegativity is less than 0.5, we have non-polar covalent bond. When the electronegativity is between 0.5 to 2.1, we have polar covalent bond. And when it is more than 2.1, we have ionic bond. So now, let us see an example here. When the two carbon atoms come together, the difference in electronegativity will be 0. As you see here, less than 0.5, we have non-polar covalent bond. Means that the bond between carbon and carbon atoms, it is non-polar covalent bond. You can check here in different dimensions and see how the molecule will behave. It is non-polar covalent bond because the difference in negativity is 0. So let us move here on the right corner, hydrogen and oxygen. The difference in electronegativity between hydrogen A and oxygen A is 1.34. As you see, 1.34, it is located between 0.5 to 2.1, which means that the bond between hydrogen A and oxygen A is the polar covalent bond. So now, as you see, at each end of a page in the molecular workbench, there is different works. The works is there for evaluation. If the runners have learned, the teacher will come and see if the runner have learned. Let us perform one example here. We have a table which shows different electronegativities. The question here, what kind of bond is formed between carbon and oxygen atom? So here we have to use a calculator. The electronegativity of carbon is 2.55 and the electronegativity of oxygen is 3.44. When we make a difference by using a calculator, we have oxygen 3.44 minus 2.55, we have 0.89. You come here, 0.89 is located between 0.5 to 2.1, means that the bond will be polar covalent bond. So the bond between carbon and oxygen is a polar covalent bond. You choose option B, then you have to check the answer. This software will give you, if you have respond correctly the question asked, and it tells you in more details as you have seen here. So what happens when you choose a long answer? For instance, let us choose an option C. If you check, they tell you, sorry, that is incorrect, and they tell you how you would perform that activity. Thanks for these multiple choices in this software, but there is another types of questions in this software which is like a unique, the questions which we call image question. Let us see a shot on the image question. In the image question, we have here a question. Use the snapshot button. Snapshot button is this, to take a picture of that molecule and use the annotation. Those annotations will come after taking a snapshot to indicate which side of the molecule is slightly negative and which side is slightly positive. Let us take this snapshot here. It has been taken. So we are going to show which part is negative. Remember, the part which is negative is where we have more electrons because they are attracted from one atom to another. Where there is a negative is where the atom lost its electrons. So now let us write those words. Here we put, and another one here. So now we are going to write, wait, you have to wait until the place where to write come. Okay, this side is positive. You click OK, then you arrange. Okay, then you come here, you write this side is negative. Okay, then you adjust. Okay, then you click OK. The snapshot will be saved here in snapshots. Then you come on the place for answering the question. You open and you drag your image in the place. From here, the teacher will come and see what is the learner has learned, and then the learner is able to submit its work. and the teacher will come and check which learner have been performed the work, which learner have been respond to the questions, and he or she may give them the feedback. So thanks for watching this demo. This is one among many importance of chemical or molecular workbench, which help us to teach easily sciences in different levels of education. Thank you. See you next time.